Transformation of a logarithmic function. Here we have f of x is equal to a times log of b times x minus c plus d. We're going to talk about what each of those variables a, b, c, and d mean. So first we have a vertical shift. That's the d value. So if we say g of x is equal to f of x plus d, that will shift f of x up d units. If we have something like h of x is equal to f of x minus c, that will shift f of x down d units. For example, here, the blue function is our parent function. We have f of x plus 2. We have f of x minus 2. The plus 2 shifts up 2 units. The minus 2 shifts down 2 units. A horizontal shift is the c value. So here we have g of x is equal to f of x plus c. We'll shift the function left c units. And h of x is equal to f of x minus c will shift the function right c units. So for example, here we have our blue parent function. When we have g of x is equal to log of x plus 2, we have that left shift. And h of x is equal to log of x minus 2, that's that right shift. So plus 2 will shift left 2 units, minus 2 shifts right 2 units. Vertical stretch and compression. So here we have g of x is equal to a times f of x. We'll create a vertical shift to the function by a factor of a. And h of x is equal to 1 over a times f of x is a vertical compression to the function by a factor of 1 over a. So again, we have our visual example. We have the blue function, log of x. G of x in this example is 3 times the log of x, which will result in a vertical stretch. And h of x is equal to 1 over 3 times the log of x. We'll have a vertical compression by a factor of 1/3. Reflections. G of x is equal to negative f of x. We'll reflect about the x-axis. And notice here, our blue parent function, if I have negative f of x, we have that vertical reflection about the x-axis. H of x is equal to f of negative x. When that negative is inside the parentheses, we have a reflection about the y-axis. So for example, h of x is equal to log of negative x. Now let's try some examples. So starting with the graph of f of x is equal to log of x, we'll use that as our parent function. Write the equation of the graph that results from each of the following. So example 1 shifts f of x 4 units down. So that vertical transformation up and down is d. So we can say y equals f of x minus 4. Or we can say y equals log of x minus 4. Example 2 shifts f of x 3 units left. The left and right, that horizontal transformation, is the c value. So I can say y equals f of x plus 3. Or we can say y equals log of x plus 3. Example 3 compresses the function f of x vertically by a factor of 1/2. So that compression, that vertical compression, is the a value. So we can write that as y equals 1/2 times f of x, or we can say y equals 1/2 times log of x. Example 4 reflects f of x across the y-axis. So that reflection, remember, is going to be either the negative in front of the function or the negative with the x inside of the function. So if it's the y-axis, it's going to be inside the parentheses with the x. So we can say y equals f of negative x, or we can say y equals log of negative x.